Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The Williamson ether synthesis requires an SN2 reaction between an alkyl halide and an alkoxide ion. SN2 reactions are favored with primary alkyl halides and hindered, eliminated, with tertiary alkyl halides. When a tertiary alkyl halide is used with a strong base nucleophile, E2 elimination dominates over SN2 substitution. Option A CH3CH2Cl, primary alkyl halide, plus Ag2O, dry, acts as a source of oxide-alkoxide equivalent. This reaction proceeds via SN2 to give diethyl ether as the major product. Ether is formed. Option B CH3, 3CCl is a tertiary alkyl halide. When it reacts with CH3CH2O, Na plus, ethoxide, a strong base, the tertiary substrate strongly favors E2 elimination over SN2 substitution. The major product will be an alkene, 2-methylpropene isobutylene, not an ether. This is the reaction that will not give ether as the major product. Option CCH3CH2Cl, primary alkyl halide, plus sodium phenoxide, Na plus OPH, undergoes SN2 to give ethyl phenyl ether, phenol, as the major product. Ether is formed. Option D CH3Cl, primary, methyl halide, most reactive in SN2, plus sodium tert-butoxide. Although sodium tert-butoxide is a bulky, strong base that normally favors elimination, methyl chloride has no beta hydrogens available for E2 elimination, so SN2 substitution must occur giving methyl tert-butyl ether as the major product. Ether is formed. Therefore, option B is the reaction that will not give ether as a major product because the tertiary substrate, CH3, 3CCl undergoes preferential E2 elimination with the alkoxide base. Therefore, the correct answer is B. Therefore, the correct answer is option B.